All right, I hope you enjoyed the triangle song there. You can find it on YouTube if you'd really like to listen to it a little bit more. Today, though, we're going to talk about the triangle inequality right up here. Keyword here, inequality. We've dealt with equalities before. This is an inequality dealing with triangles. And I'm just going to go through the sheet, and you can compare your answers. If you need to stop and pause this to check out what you have versus what I have, please do so. Make sure that you have everything filled in, though, so that you have a good set of responses for your notes. All right, the first task you had was to go ahead and draw yourself a scalene triangle and measure the angles and measure the sides. So you can see that I did that over here. My scalene triangle had sides of 3, 4, and 5. And when I used my protractor, I got angles of 36, 55, and 89 degrees. So, that's just your generic scalene triangle right there. And, my angles end up adding up to 180. Yours should be close to that. After measuring each side to the nearest tenth and each angle to the nearest degree, you are asked to describe a relationship between the location of the longest side and the largest angle. So my longest side is definitely 5. My largest angle is definitely 89. So it looks like the relationship is that the 5 is opposite the 89, that the side is opposite the largest angle. And in fact, number 4 says describe the relationship between the shortest side and the smallest angle. So again, if I come in here and look at my smallest side, which is 3, my smallest angle is 36. Opposite the 36 is the smallest side of 3. And I guess that would then leave, the middle side, even though the question wasn't asked, the middle side is opposite the middle angle. So there is definitely a relationship between angle size and size of the side opposite it. So again, if you need to pause this and write it down, I know my writing's a little messy here, but I wrote that relationship down, that in number 3, the largest side is opposite the largest angle, and in number 4, the shortest side is opposite the smallest angle. We don't say that they're parallel. It's impossible for an angle to be parallel to a side. We're talking just opposite in terms of not being adjacent. Finally, for number 5, it says, for any triangle, the longest side must be opposite the largest angle, and the shortest side must be opposite the smallest angle. We just said that. Explain why it's impossible to draw a triangle where the longest side was not opposite the largest angle. Now, we had a couple of people ask about this in class today, and I think that really what we want to do is talk about angles being measures of spread. That what is determining the length of the opposite side? Well, the opposite side is determined by how spread out the angle actually is. So if you have a small amount of spread, you don't require a very long length to connect the endpoints to make that a triangle. If you have a very large spread, which means a large angle, you need a much larger side. So it's really the angle spread that determines the length, and therefore bigger spreads need bigger lengths. The bigger the angle, the bigger the length opposite it's going to be. So that would be a good response for that. And finally, the last thing goes on to say, explain why a scalene triangle can never have 2 congruent angles. If you know that 2 sides in a triangle aren't congruent, then the angles opposite them are also not congruent. It's kind of like a corollary to the base angle theorem for isosceles triangles that we had talked about before. Just going with that. We would need to have 2 equal spreads to have equal lengths of sides opposite. And again, since a scalene triangle can't have 2 sides of the same length, going backwards, it can't have 2 angles of the same spread to match up with that, therefore making it impossible for it to have 2 congruent angles. All right, moving on to the next page. You were supposed to do some work with your spaghetti. And here are the numbers that I got. If you didn't complete your tables, you can go ahead and use my tables. I apologize that at times I got my small and mediums mixed up, like here. These should really be reversed, but in all honesty, it doesn't matter which cell they go in. You clearly do want your 2 smaller values to go into small and medium, your largest value to go into large. So you'll see my first triangle, 3, 4, 5. That was the one that was on the first page. 3 plus 4 is 7 in the last column. And I did that for each of my 3 different triangles that I was able to make out of my spaghetti. One of the things that I definitely noticed, and hopefully you noticed too, is over here, this small plus medium column, when looked at in comparison to the number right next to it, the largest side of that particular triangle, each time my small plus medium was bigger than my largest side. Okay, that is an important fact because when we get to the next table, which was the one where you couldn't make the triangle, you'll see my small plus medium in the first one is equal to 5 with a large side of 6.2. Small plus medium in the second one was 4.7, large side 7, and then 3 and 4.4, 7.4 compared to 8.3. That, again, comparing these with each of the large sides in the triangle, now you see the opposite relationship. Whereas in the top, small plus medium was greater than large. In the bottom, small plus medium is less than large, which is really what the triangle inequality says. All right, so in number 5, it asks to make a conjecture. We talked about a conjecture the other day being very much like a hypothesis. What do you feel is a relationship here between the small, medium, and large sizes? So my conjecture would be that the small plus the medium being greater than the large means that I can have a triangle. And that if my small plus medium is less than the large, I'm not going to get a triangle. You should pause right now and double check your table and see whether or not you have the same relationship. If not, it'd be really interesting to see if you could maybe go to your pantry and grab a piece of spaghetti and see whether or not you truly could create the triangle of the size that you said. Because if the small plus the medium is less than the large, then you are not going to be able to make a triangle out of it. You're going to get a scenario where you get something like this, where you have 2 pieces and then you have like this long piece, and that's not going to make a triangle. You need a minimum of a little bit more than the long piece to make this the two smaller pieces. So I happened to check my conjecture, and yes, in fact, it does work. So is it possible to have a triangle such that the sum of the measures of the small and the medium size is equal to, so this is the key word here, equal to the measure of the large side? Provide a convincing reason for your answer. Well, if I have 3 pieces of pasta, let me say that this is 1, this is also 1, and this is 2. Can I put those together to get a triangle? And what you would notice is if you did do that, if I laid the 1 and the 1 end to end with each other, and I'm just going to put a kind of a midpoint here so you can see it. So if this is 1 and this was 1, and my second piece is a 2. So how am I going to span the 2 over that to make a triangle? Well, since 1 plus 1 is equal to 2, if I put the 2 right over the 1 and the 1, they would lay on top of each other, basically forming a line segment. If I started to bend the 1 and the 1 up at all, I mean, I know that this is a little bit bigger, but if I bent the 1 and the 1 up and I kept the 2 the same way, it would be too big for the angle that it spans. And what we have here is if you have this equality, this equal piece, the only way for the 2 to be equal is for them to be perfectly flat, like in this scenario. And that is not a triangle. There's no angles there. They're right on top of each other. So that would be my reasoning for why the answer is no, they cannot be equal. Okay? It is a straight inequality, hence triangle inequality. For number 8, it does say if the sum of the measure of the small and the medium angle is greater than the measure of the large side, we can conclude that the sum of the measure of any pair of angles will be greater than that of the large side. So what they're saying is if the small plus the medium is greater than the large, then we can conclude that the sum of any two sides would be greater than the third side. So if I took, since the small and the medium produce the smallest possible number, the smallest possible number is bigger than the largest possible number, then if I say small plus large, that has to be greater than medium. And if I say medium plus large, obviously it has to be greater than the smallest. So it doesn't matter what the numbers are. If this relationship holds, then these two relationships must hold. If the two smallest numbers are bigger than the largest number, then any combination of numbers is bigger. All right, so let me give you an example of this. If I say, 3, oops, that's not a pen, 3 plus 4 is greater than 2. So 7 is definitely greater than 2. Isn't it also true that 3 plus 2 is greater than 4, and 2 plus 4 is greater than 3? That there's no way in which I could write this combination such that these two would be incorrect. If this is a correct statement, these two will also be correct statements. All right, let's try to generalize on the next page. So if you can look down here at my triangle for a second. Notation-wise, I have triangle ABC, and opposite angle A is little a, opposite angle B is opposite angle C is little c, opposite angle B is little b. So we denote the side lengths by lowercase letters based on the vertice that they're opposite, or based on the vertex they're opposite. So really what the triangle inequality says is that if I take the two smaller pieces, so C plus B are the two smaller pieces, that has to be greater than A. And if that's true, then I can say, okay, let's take C plus A, that has to be greater than B, and then the other combination is A and B together. So A plus B has to be greater than C. So that right there, that is the triangle inequality. We can write it a different way. So down at the kind of the next piece down says, write it using the distances, not the small lowercase letters. So if I look up here, C, which is this piece right here, right? C is really segment AB, so length AB. B is really AC, and then that has to be greater than BC. I can do that again, that AB, so C plus A, well, A we said is BC, so AB plus BC has to be greater than AC, and then the last one is that AC plus BC has to be greater than AB. So this is another way of looking at the triangle inequality. First way using actual side lengths. The second way is using distances between vertices. Sorry about that. All right, so here's example 1. Write the side lengths in the order from least to greatest. Well, the first thing that I'd like you to consider is that it's missing an angle. So 111 plus 46, 5 is 157. This whole thing needs to add up to 180. So that means that there are an additional 23 degrees that I have missing. So this is a 23-degree angle right here. So in terms of writing the lengths in order from least to greatest, the smallest has to be opposite the shortest side. The smallest side is opposite the smallest angle. The largest side is opposite the largest angle, and then the medium's opposite the medium. So looks like CB is the shortest side length, followed by the medium side length, which is going to be AC, followed by the largest one, which would be AB. So these are the side lengths written in order from least to greatest. If you wanted to, you could call this little c, call this little a, call this little b, and we could have that CB is A, that is B, and that AB is C. So you could have written it like that if you denoted the side lengths. Moving on, it says based on the triangle inequality, is it possible for the following sides to be sides in an angle? So again, the triangle inequality states that the small plus the medium has to be greater than the large. So we can take the first one right here. We just basically are going to do a check. And the question will be yes or no. So is 2 plus 2 greater than 5? Is 2 plus 5 greater than 2? Is 5 plus 2 greater than 2? Well, right off the bat, is 2 plus 2 greater than 5? No, it is not. So 2, 2, 5 is not a possible triangle. Cannot make a triangle of 2, 2, 5. For the second one, is 4 plus 2 greater than 5? Is 4 plus 5 greater than 2? Is 5 plus 2 greater than 4? So that's A plus B greater than C, A plus C greater than B, B plus C greater than A. And in this one, since again the two smaller ones are greater than the largest side, it falls in line that all three are, so this is a triangle. And finally, 3 plus 2 greater than 5, 3 plus 5 greater than 2, 2 plus 5 greater than 3. Are those all true? Well, right off the bat again, is 3 plus 2 greater than 5? It is not. They are equal, and it has to be greater than, strictly greater than. So it doesn't matter that these two are true. This one being false means that this is not a triangle. Problem number 1 had you given the angles, list the sides in order from least to greatest. Example number 3 has you going the other way. If you know side lengths of 5, 9, and 14, can you list the angles in order? And since this is a single triangle, we can get away with naming the angles with their single letters. Opposite the largest side is the largest angle, so we know that E is the largest. So angle E is going to be the largest. 5 is going to be opposite D. That is going to be the smallest. So angle D is the smallest, which means that angle R is right in the middle. So that is, when it says in ascending order, that means smallest to largest. So smallest angle D, largest angle E. Last set of problems here. In example number 4, it says that a triangle has two of the lengths of 4 and 17, and to describe all of the possible lengths. Well, there are lots of possible lengths for the missing side, which I'm referring to as X. So the way in which I'm going to get these is I'm going to set up the 3 triangle inequalities that must be true. I know that 14 plus 17 has to be greater than X. I also know that 14 plus X has to be greater than 17. And I know that 17 plus X has to be greater than 14. All 3 of these statements need to be true. Well, the first one, 14 plus 17, is 31. So this says that X has to be less than 31. That X cannot be bigger than 31 or else it won't be a triangle. In the second inequality, if I subtract 14 from each side, I get that X has to be greater than 3. So X has to be less than 31, greater than 3. And then the last inequality, if I subtract 17 from either side, I get that X has to be greater than negative 3. Well, of course X has to be greater than negative 3. It has to be a positive number, so I don't even have to worry about it. So if I want to describe all of the possible lengths of X, I know that X has to be greater than 3. I know X has to be greater than 3 and has to be less than 31. For the last one, it says in triangle ABC, B is obtuse and the measure of angle A is less than the measure of angle C. So I tried to draw you an obtuse triangle with that characteristics. State what you know about the lengths of the sides. Well, again, this is just about an ordering things. I don't actually know anything about the lengths of the sides, but I know that B is the largest length because it's opposite the largest obtuse angle. You can only have one obtuse angle in a triangle. And if I know that the measure of angle A is less than the measure of angle C, then I know that A must be the smallest, and I know that C must be the middle. So if I were to put them in order, I would say that it goes A, C, B, smallest to largest. All right, hopefully that helps out. Take a look at the homework. It should make sense. Again, there's not a whole lot of math here. It's more about ordering things. And really, these problems right here are really the trickiest of them because you have to set up the inequality and get an answer that looks like this. All right, best of luck. See you tomorrow.